Hello there, children. Today we are going to work with solving logs, or logarithms if you want to be fancy. Now, this problem here, we have a log equaling log. Luckily for us, that is the one-to-one property of logs, which states the following. If I have the same base, which is base 20 here, and I have one log equaling one log, I am allowed to simply cancel those logs out, or you could say exponentiate both sides, but for lack of a better term, I can set the interiors equal. Just like our property of exponents, if I have the same base, the exponents must be equal. In this case, if I have the same base, the arguments of the logs, or the inside of the logs, must be equal. Now from here, what I'm going to do then is simply subtract 2x, and I am going to add 5 to both sides. Now, when I do this, I am going to get x equal to 9. Now, before I circle it and go, woo, whoop, yay, I've got to make sure that it does not make the inside of my log negative. If I put 9 in here, 3 times 9, 27, 27 minus 5, 22. 2 times 9 is 18. 18 plus 4, 22. So it works. Remember, you are not allowed to have the inside of a log be negative. Moving on. Here again, log equaling log. Now, wait a minute. I don't see a base here. Oh no! Oh wait, that's right. When there is no base, it is the common log, or base 10. So again, I do have a 10 here. I just don't write it. Just like you don't write that x has a coefficient of 1, or an exponent of 1, or divided by 1. That's quite redundant. We don't need to do that. So we don't. And the common log is so, dare I say, common, that it doesn't really get written. So I go like this. V plus 6 equals 2v plus 1. Now, when I do this, again, you have to solve. I am confident that everyone here can solve this problem. Well, this time I'm going to bring everything to the right, not to the left, I can switch if I wanted to. So I'm going to subtract 1. And get 5 equals v. Now I put 5 in here. 5 plus 6 is 11. 2 times 5 is 10. 10 plus 1, 11. So we're good. All right. Moving on. All right, here I have log equaling log. Again, base 10, so I set the insides equal. The only part here I've got to worry a little bit about is the fact that in this particular problem, I've got quadratics, which means I need to set it equal to 0. I'm going to just move everything over to this side of the problem, which means add 3n squared and subtract 42. Now, why am I adding 3n squared? Remember, I would like to have the n squared being a positive number. That's my whole stated goal here. It makes things nice. So this would be a 42. Now, when I do this, I set it equal to 0 because that's what I do with quadratics. So I end up with this. Now, this will test your factoring abilities again, folks, which luckily I am fairly confident all of us can factor, because factoring is fun, and our friend. Give me two numbers that multiply to negative 42, but add to that negative 1, that would be an n minus 7 and an n plus 6. Now, if you're a little concerned about how you factor this, right, when in doubt, you FOIL it out. When in doubt, you FOIL it out. You when in doubt, you FOIL it out. And you get back to this, hopefully. Now, with all of these, I set each equal to 0, and I solve. N equals 7. All right, let's put 7 in here and see what happens. 7 squared is 49. 49 times negative 2, negative 98? Negative 98 minus 7, oh, negative 105? Ugh, no, not okay. Negative inside of the log can't happen. We've been over that. So, you're not a good solution. All right, let's go to this other one. Subtract 6 from here, I get n equals negative 6. Let's go put that in. All right. Negative 6 squared, 36. 36 times a negative 3? Oh boy. That doesn't look too promising to me. And lo and behold, folks, it's not promising. And here's the reason why. When you take 36 times 3, you get negative 108 there. And when you do 42 minus 108, you get negative 66 in here. Well, guess what? You can't have the inside of a log be negative, so you're not good either. So I thought I had two answers. Turns out none of them actually worked, so I have a no solution problem. That problem is no solution because I don't have a viable answer to my question. I thought I had two. They don't work. Now, if one of them worked, I would circle that and be like, all right, one didn't work, but one did. But it turns out in this case, neither of them did. All right, this is no longer log equaling log, however. This is two logs equaling a number. So, all of our properties are log equaling log, or condensing items to a single logarithm. Now, what that means is, like Humpty Dumpty, we're going to bring it back together again. But unlike Humpty Dumpty, we have mathematics, so we're good to go. The addition symbol there brings my logs back together as one with multiplication. Now, don't forget, sharing is caring. Thank you, imaginary voice in my head. So I share the 10. And when I do that, I get an item like this. Now, we are going to turn this from log to exponential form, and here's why. That 10x is trapped inside my log. So like what some of you do with your parents, if one doesn't give you the answer that you want, go ask the other one. Log form is not going to give me a viable solution. Go ask the other one. The other form being exponential form, which gives me this. Now I am fairly confident everyone here can solve this problem, so let's go ahead and do this. I'm going to add 30 and divide by 10. And I get 38 over 10 equals x. But guess what? That's not the answer because I can divide both by 2. That is the answer, or the decimal approximation of that. Moving on up in the world. All right, this problem again. Let's bring it back together. Bringing it back together, the addition comes back together with multiplication. Negative 2x times 8, negative 16x. Again, the x is trapped inside there, so I'm going to go turn it into exponential form. When I do that, I get 4 to the first equals negative 16x. Now, I get 4 over negative 16 equals x. Uh-oh. Now, I know what you're thinking. I should really check this answer. And you're right, I should. It can't make the inside of a log negative, and I'm really concerned because I have a negative 1/4. But if I look here, negative 2 times that negative 1/4 is a half. 1/2. Positive 1/2, which means it's still a viable answer. So we're good. Moving on. Again, little Humpty Dumpty work here. Now I have two logs equaling a log. I know what a lot of you want to do. You want to go 3x plus 7 equals 77. Cancel all the logs. Yay! No. No, no, no. No. We don't have a property that's a 2-to-1 property of logs. I've got a 1-to-1 property of logs. I don't have a 2-to-1 property of logs. So what I've got to do is I'm going to have to bring these back together again. Come together right now with mathematics. Multiply them together and get 21x. Now, what's really neat is now I've got log equaling log, exactly what I was looking for, which now allows me to cancel out the logs because I have the same base, which means these interiors must be the same. So I get 77 over 21, which reduces down to 11 over 3, dividing both by 7. Moving on up in the world. All right, this one. Now, this is the first time I've seen subtraction. Now, subtraction looks awfully like a division bar, which it is. So I'm going to do 10 divided by x minus 3, this being the bottom portion, equals 5. I've got one log now. Now I can turn it into an exponential function. Now I know what you're thinking. Well, what happens from here? Well, I get 2 to the 5th equals this particular item, 10 over x minus 3. Well, how the heck am I going to get x minus 3 out of the denominator? I'm going to do a little cheat here. I'm going to multiply both sides by x minus 3. I'm allowed to do that. Now this becomes, let's go, 4, 8, 16, 32. Neat. Because those two would cancel. So now I just keep on trucking. I get 32x minus 96 equals 10. I'm going to add 96 to both sides, equaling 106 here, and dividing by 32. So I get x equals 106 over 32. Not the final answer, and why not? Well, they're both even. So if they're even, that even's leaving. And 53 over 16, or the decimal approximation of that. Moving on. All right, again, some Humpty Dumpty work needs to be done here. Addition back together with multiplication. Now, the only thing goofy about this problem is, if I look here, I think that I am awfully close to heading for, I'm just a little concerned here, maybe. I do my little loop diagram, and I'm a little concerned. I see 9 squared. Now let's take x and distribute it in here to both those. Yep, definitely right. I see a quadratic. Well, all right. I'm going to subtract 9 squared from both sides. Remember, 9 squared works out to be 81. So I end up with this. Now, I want to know what are two numbers that multiply to a negative 81, but add to a 24x. Let me ponder here. Ponder, think, like Winnie the Pooh. Oh, positive 27 and a negative 3. Well, this gets me an x equal to 3. And this gets me an x equal to negative 27. Well, kind of. Putting 3 in here, 3 plus 24, 27. Cool. Putting 3 in there gets me a 3. All right, 3, you're good to go as an answer. You don't make the inside of a log negative. Negative 27. Negative 27 plus 24, negative 3, oh bother. The inside of the log becomes negative, so I can't have that. So no negative logs. Bummer. So I do have a correct answer of 3. The problem is negative 27 does not work. That's okay though. All right, this one. Let's Humpty Dumpty this back together again. Again, a subtraction, which means division. Do our little loop. I get 8 to the first equals x squared minus 10 over 6. Remember our little loop here. Eight to the first is 8. Now I'm going to multiply both sides by 6 here. That's going to give me 48 equals x squared minus 10. Now I know what you're thinking. Set it equal to 0. But remember, when I only have an x squared, I can just simply add 10 and square root. Now when you square root this item, you are going to get plus or minus root 58. Remember, square root both sides here. Now if I put plus or minus root 58. When I square that number, I will get 58, whether it's a positive or negative version. Subtracting 10 from that, that's okay and it's not negative. So this is a good solution. Moving on. Last but not least, oh man, saving the best for last. All right, bring them back together, bring it on back. With multiplication, with one log, doing our little loop here. And now we go from there. Now this involves some FOIL action. Let me just see if I can magically pop it up. Poof! Math. Alright, so now what I've got to do is take negative 29 and subtract 64 from that and see what I get. Because I need to set it equal to 0. So I get x squared plus 28x minus 93 equals 0. So I need to find two numbers that multiply to a negative 93 and add to a 28. Well, that would be x plus 31 and an x minus 3. That equals 0. Now, if I go ahead and solve these, I get x equal to negative 31 and x equal to 3. Cool beans. 3. Do you make that log negative? 3 minus 2, or 3 minus 1, excuse me, 2. No. 3 plus 29, positive number. All right, 3, you're in the club. Congratulations. Negative 31. Negative 31 minus 1. Oh, that's negative 32. Sorry, buddy. You're out. Because remember, the second it makes any inside of a log negative, that's no good. You have now reviewed solving logs. Go henceforth and do.